Hi, 8th grade. Welcome to lesson 3-6, sketch functions from verbal descriptions. By the end of the lesson, I want you to be able to say, I can sketch the graph of a function that has been described verbally. Let's explain it. The Environmental Club is learning about oil consumption and energy conservation around the world. Jack says oil consumption in the United States has dropped a lot. Ashley says oil consumption in China is the biggest problem facing the world environment. Do you agree with Jack's statement? Construct an argument based on the graph to support your position. So I want you to say if you agree or disagree and say why. Okay, so the United States is in the pink. So if we follow the pink, it starts below the 2000, then it increases, then it decreases. So I don't support Jack's statement of saying oil consumption in the United States has dropped a lot. I think because based on the beginning, it started lower, then it increased, then it decreased. So it ended up being the same as it was, or around the same as it was 10 years ago. So no, because it increased, then decreased. Do you agree with Ashley's statement? Construct an argument based on the graph to support your position. So Ashley says that China is the biggest problem facing the world environment. China is this bluish purpley color. Started off low and then it increased over the 10 years. So I agree with Ashley, yes, because it has increased the most. Because if it were to continue on this trend, it would only get worse and worse. Focus on math practices. Look for relationships. What trend do you see in oil consumption in the United States in Europe? So Europe is the green and United States was the pink. I see that they both look relatively constant. They're both constant. Remember, constant means flat, barely any increase or decrease. Example number 1. Oops. Sketch the graph of a linear function. A scuba diver starts a dive with a full tank of oxygen. While diving, she breathes at a constant rate. She checks the gauge after 22 minutes. What does a graph of a function look like? What happens to the oxygen level in the tank over time? So she's breathing every time. So she takes in that oxygen and blows it out as bubbles into the water. So the input variable is time. Remember, x. Input is the x value, and output is the oxygen level in the tank. So when 0 time is passed, that's our y-intercept, she has the most amount of air in her tank. But then as time passes, the amount of air in her tank decreases. The slope is negative. All we're doing for today's lesson is just sketching the graph of a story they tell us. Let's try it. The weight of the water exerts pressure on a diver. At a depth of 10 feet, the water is about 19.1 pounds per square inch. At a depth of 14 feet, the water pressure is 20.9 psi. Complete the statements and then sketch a qualitative graph of this function. So the input is the depth. How many feet? So that's the x value variable. And the output or y value is psi. How much pressure is being put on the diver? And if you've ever been in a diving pool or a swimming pool, and you swim all the way to the bottom, your ears start to hurt. That's because the pressure is increasing. So when there is 0 depth, there's 0 pressure. But as our depth increases, so does the pressure. How are sketches of the two functions similar? How are they different? Well, both sketches are linear, but one was decreasing and the other increasing. All right, example number 2. Analyze a sketch of a nonlinear function. Danica sketched the relationship between altitude and time for one of her ski runs. Describe the behavior of the function in each interval based on her sketch. Well, the first one, we start at 0 time and 0 altitude, and then as time increases, her altitude increases. It's an increasing function, a positive slope. So that part, Danica's on the chairlift going up to the top of the ski run. Then her slope is 0. It is constant, which means Danica is at the top of the run waiting to ski down. Her altitude isn't changing because she's not going up or down. Then we have a negative slope. It is decreasing, which is when Danica is skiing down the run. So her altitude is decreasing because she's going down the hill. Example 3. Jose is practicing javelin throws. What is the relationship between the height of the javelin and time? What would the graph of this function look like? So step 1, identify 2 variables in the relationship. So the input, the x, is time, and the output is height. So at what time after you throw the javelin is the height that the javelin is in? Analyze the relationship between the 2 variables. So when Jose first throws the javelin, it increases in height. It goes up, it reaches its maximum height, and then it decreases until it hits the ground. So it's going up, going up, going up. Then Mr. Gravity takes control and goes down, 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 down. So if we were to sketch the graph, here we go. It's going up, increasing, and then it reaches the maximum height, can't go up anymore. So what goes up must come down. When we are sketching a graph, it does not have to be perfect, but it does have to look realistic. So let's try it. Haru rides his bike from his home for 30 minutes at a fast pace. He stops to rest for 20 minutes and then continues in the same direction at a slower pace for 30 more minutes. Sketch a graph of relationship from his distance from home over time. So time is 0. That means he hasn't gone any distance. He's going to ride his bike at a fast pace. If it's a fast pace, should it be a steep hill or should it be not so steep? It's going to be steep. So he's riding his bike fast. Then he stops and he rests. If he rests, is his distance increasing? No. So we are constant. And then he's continuing in the same direction. So that means he's still going farther away from home. But this time he's not going as fast because he's a little tired. So our line is not going to be as steep. And that's all it is. There's our sketch. All right, 8th grade, let's say it. Sorry about that. All right. I can sketch the graph of a function that has been described verbally. Have a great day.